Okay, C12, June 2017, question number 7. Here we have a question about graphs and transformations of graphs. Figure 3 shows a sketch of a part of the curve with equation y equals f of x. So we do not know the equation of the actual function. Okay, we just have the drawing part of it. The curve crosses the y-axis at the point 0,8. And the line with equation y equals 10 is the only asymptote to the curve. So there's a part of this curve, which is this part on this side, which will never touch the asymptote, okay, the part on this side of the curve. The curve has a single turning point, a minimum point at 2,5, as shown in figure 3. That's the minimum point, the lowest point it gets to. Part A says, state the coordinates of the minimum point of the curve with equation y equals a quarter x. So I'm just going to answer the question over here. Alright, so y equals a quarter x, y equals f a quarter x. Now, what this means is, okay, with transformations, what we know is that if there's a transformation that takes place inside the function, like inside the bracket, okay, then that's something which only affects the horizontal kind of transformation. It's like a horizontal transformation. So it only affects the x values of the graph. Okay, it will not affect the y values. If it was y equals a quarter f of x, then this would affect only the y values and leave the x values unaffected. Okay, but that's not what we got. We got this. So the x values are affected, okay, the y values are unaffected. But when something's inside the function like this, it actually acts in the way which is opposite to what we normally might think. So if it was y equals a quarter times fx, the y values would be multiplied by a quarter and the x values would remain unchanged. However, if it's f a quarter x like this, it is the y values that remain unchanged and the x values which are multiplied not by a quarter but by its reciprocal, which is 4. So the minimum point is 2,5. Okay, so the minimum point is 2,5. So I'll just answer over here so we can see what's going on. And you're going to take the x value and multiply it by 4, and the y value will remain exactly as it is. So your answer is going to become 8,5. That's going to be the new minimum point of the curve. So the x values are changed, okay, it's basically going to be multiplied by 4, so it's going to be out here somewhere, and the y values will remain unchanged, so it's going to turn somewhere further out over here. Okay, it'll be over here somewhere. Okay, so that's what happens with transformations which are inside the function. This is like called a horizontal stretch of factor 4. Opposite of what the reciprocal of the number that's multiplying the x inside the function. Then it says state the equation of the asymptote to the curve with the equation y equals f of x close bracket minus 3. So again, this here is a function, this here is a transformation which affects which is like outside the function. Okay, it's not the same as this. This is when it's inside the function. Okay, so this here will affect the x coordinates, and this one affects the y coordinates. Okay, now when something's outside the function, it acts kind of in the way we normally would expect. Okay, so if it says f of x minus 3, this is a this is a vertical translation, okay, of 3 units down. So this is basically when you take the x value and leave it as it is, and the y value you take away 3 from it. So it's like described by this vector 0 minus 3. So every point is moved down by 3 spaces, and horizontally it stays the same. So the asymptote was y equals 10. So you're going to it's going to go down 3 spaces. It's going to become y equals 7. Okay, all these points are going to move down 3 spaces, everything. So the asymptote will now become y equals 7. Okay, the answer for part 2. All right. And then it says the curve with equation y equals f of x meets the line with equation y equals k, where k is a constant at 2 distinct points. State the set of possible values for k. So y equals f of x is going to be like a line which is horizontal. Okay, and that here this is when y equals 10. Okay, y equals k is a horizontal line. Okay, so at this point, that's the same as the asymptote, y is equal to 10. Alright, so here the value of k changes. This is when k is 0, k is minus 1, k is 1, k is 5, k is 8, k is 10, and so on. Okay, so this is the line y equals k. Now the question is telling us that the y equals f of x meets the line with the equation y equals k, where k is a constant at two distinct points. Two distinct points. So if you look here and everywhere above here, it's going to meet, this is going to meet the curve at one point only. Okay? When you go below the asymptote, it's going to meet it at two distinct points. So when y is less than 10, okay, it'll meet it at two distinct points, and it'll continue meeting at two distinct points until we get to y equals 5. Okay? At y equals 5 exactly, it's going to meet it at one point, which is at the turning point. Okay, so when y is above 5, up to the point where y is just below 10, it's going to have two distinct points where this line y equals k and our curve intersect. Okay, so the range of values for k is going to be between 10, less than 10, but more than, what was it, 5 I think? More than 5. Okay, k has to be between 10 and 5, okay, for there to be two distinct solutions. Okay, that's part C. And part D says, sketch the curve with the equation y equals minus f of x. On your sketch, show clearly the coordinates of the turning point, the coordinates of the intersection with the y-axis, and the equation of the asymptote. So I'm just going to draw it on the same sketch here where I'm not supposed to actually. In fact, I won't. I'll actually do it on the next page, because you're not really supposed to do it here. So they normally give you some blank space to do it in. Yeah, I'll do it here. Okay, so let's draw axis. It's going to be below the, most of the stuff's going to be below the axis now. Okay, what I'm going to do is actually, I'm going to take that sketch from there, just lock this in place. Okay, I'm going to take the sketch that we have already. Okay. Take it, put it here so we can see what's going on. Okay, so I'll make it. Okay, so we see what's going on up there. So we have your x-axis and your y-axis. Okay, now we're drawing y equals minus f of x. Y equals minus f of x. Let me just confirm that. Okay, so again, this is something which is taking place outside the function. Okay, so that means all the y values change and the x values remain the same. Okay, because it's outside the function. So for example, the point 0.8, okay, if you have y equals minus f of x, the point 0.8, okay, the x value remains unchanged, but the y value just changes its sign. And the point 2.5, the x value remains unchanged, the y value changes its sign. Okay, and what other point do we have? And yep, and the equation y equals 10 becomes y equals minus 10. The asymptote changes it. All right, so let me just do a little bit of a cheat. It's going to work. Yeah, I just a bit of a tracing of that graph, how it looks earlier. Paste it here. So this is how the graph looks. Something like this. okay, before, yeah, it's a bit bigger. Okay, this is before the transformation. Okay, it looks something like that. Okay, now after the transformation, this point here goes down to here. Okay, and this point 2,5 goes, okay, to 2 and -5. So this is 8, 0, 8. So this is going to be -8. This is your 2, and that's 5. This is going to be -5. Okay, the point over there. Okay, and then you're going to have your asymptote, okay, which I'll do as a dotted line. Okay, it's going to go through -10. Okay, that's going to be y equals -10. That's -10. That's y equals -10. Okay, so your graph will look something like this. Let me take this one here. Choose it. Sorry about that, 1 second. Come on. I'm supposed to be able to choose it. Okay, so I'm going to take this. Take this. Anyway, I'll give up with that, sorry about that. So what I'm going to do is just draw it as a, what happens when you try and cheat. Okay, so now, basically, it's going to go something like this. Okay, it's going to be a reflection of that in the x-axis. So it's going to turn upwards, it's going to come like this. Okay, on this side, it doesn't matter, it crosses the asymptote. Okay, it's going to come like this, and then it's going to go like that. And this side, it's not going to reach the asymptote. Let me fix that a bit. It's making it reach it. All right, so there we have our y equals -f of x. Okay, and there is part, I think that's part D, and we finished the question. 7 part D. Yep. Okay. There we have it. Thank you for watching. Well, we should put these points, by the way. This is 2 and -5, y equals -10, and this point we've mentioned as well. Okay? So there we have it.